Hello, my name is Danielle Goldsmith, and the title of my experiment is Paper Airplane Acceleration. I go to North Seattle College, and I am in an Intro to Physics class with Dr. Azeda. My research question is, how do mass and force affect the acceleration of a paper airplane flying across the room? For this experiment, I will be talking about Newton's second law of motion, and this states that force equals mass times acceleration, or net force is equal to mass times acceleration. A larger net force acting on an object causes a larger acceleration, and objects with larger mass require more force to accelerate. Force is defined in science as a push or a pull on an object. Mass is the amount of matter in an object or its resistance to a change in position or speed in response to a force. Acceleration is defined as the rate at which an object's velocity or its speed is changing over time. My hypothesis is, based on the definitions of these variables and Newton's second law of motion, I predict that increased mass will decrease acceleration and increased force will increase acceleration. When force and mass are both doubled, acceleration will remain constant, and when force is doubled and mass is halved, acceleration will increase fourfold. For my experiment, I used problem 17 from chapter 4 of the college physics textbook, and chapter 4 is titled Forces and Newton's Laws of Motion. So problem 17 stated, a constant force is applied to an object, causing the object to accelerate at 8.0 meters per second squared. What will the acceleration be if the force is doubled, the object's mass is doubled, the force and the object's mass are both doubled, and the force is doubled and the object's mass is halved? While doing this problem, I chose to use a paper airplane as my specific object for this experiment. In order to double the mass of the paper airplane, I put a folded up paper airplane in the middle of the original plane. I measured the distance from my door to my wall, and I threw a paper airplane 5 times with varying force and mass across the room. In order to find the acceleration of the paper airplane, I measured how far the paper plane had to fly each time and how fast it reached its destination despite changes in mass and force. While I threw the plane twice as hard when I needed to double my force, in order to calculate the force numerically, I calculated mass times acceleration. This chart explains the results that I got, the acceleration, the mass, and the force for each of my 5 paper airplanes and how they vary based on the differing mass and force at which the paper airplane was thrown. This is the graph that I created using Logger Pro. So when analyzing my results, I found that paper airplane 1 was the control group, and its mass was 0.005 kilograms, and the force used to throw it was 0.000381 newtons. Its acceleration came to about 0.762 meters per second squared. In variable 1, I doubled the force used from 0.000381 to 0.00075 newtons. The mass remained constant at 0.0005 kilograms, and as expected, the acceleration doubled to 1.52 meters per second squared. In variable 2, the mass was doubled from the control group to 0.001 kilograms. The force remained the same as the control group at 0.000381 newtons. As expected, the acceleration was halved to 0.381 meters per second squared. In variable number 3, the force and mass were both doubled, so force was now 0.00075 newtons and the mass was 0.001 kilograms. As expected, the acceleration remained roughly the same as the control group, which was 0.75 meters per second squared. While not exactly the same, it was very close. And in variable number 4, I doubled the force and halved the mass. The new force was 0.00075 newtons, and the mass was 0.00025 kilograms. The acceleration grew fourfold as expected to 2.9 meters per second squared, while it should have been 3 other variables such as wind or drag could have affected these outcomes. In conclusion, all of my results support the idea of Newton's second law, which states that force equals mass times acceleration. And as you see based on the experiment, when the force was doubled, acceleration was also doubled, but when the mass was doubled, acceleration was halved. When force and mass were both doubled, acceleration remained constant. So overall, based on the experiment, we can see Newton's second law take place in real life.